sklearn, utils, sparsefinx, mean variance access. Description. This function computes the mean and variance of a sparse matrix along a given axis. It leverages the efficiency of sparse matrix operations to avoid unnecessary calculations on zero elements. Inputs. X a sparse matrix of shape n samples. N features. Access an integer representing the axis to calculate mean and variance along. 0 for row-wise sample-wise calculations and 1 for column-wise feature-wise calculations. Outputs. Mean an array containing the mean values along the specified axis. Variance an array containing the variance values along the specified axis. Steps. Calculate the mean of the non-zero elements along the specified axis. Calculate the squared mean of the non-zero elements along the specified axis. Calculate the sum of the squared non-zero elements along the specified axis. Calculate the variance using the formula variance sum of squared non-zero elements, n non-zeros. Squared mean. Metrics. Efficiency. This function efficiently computes the mean and variance by exploiting sparsity. Accuracy. The computed mean and variance are accurate for sparse matrices. Visualization plots. Scatter plot. Visualize the distribution of values along the specified axis with mean and variance. Highlighted. Histogram plot. The histogram of values along the specified axis with mean and variance indicated. Fine-tune parameters. Axis. The choice of axis determines the direction of the calculation rows or columns. Uncertainty methods. Confidence intervals. Calculate the confidence intervals for the mean and variance using statistical methods. Bootstrap. Resample the data multiple times and calculate the mean and variance for each resample. To estimate the uncertainty. Challenges and fixes. Challenge 1. Handling very sparse matrices with a small number of non-zero elements. Sample use case that resulted in challenge 1 is sparse matrix with a high sparsity level where the number of non-zero elements is significantly less than the total number of elements. Fixes to challenge 1. Use appropriate data structures and algorithms that are optimized for handling sparse data. Consider using alternative methods for computing mean and variance if the sparsity is extremely high. Challenge 2. Numerical instability for matrices with very large values. Sample use case that resulted in challenge 2 a sparse matrix with extremely large values in some of the non-zero elements. Fixes to challenge 2. Normalize the data before computing mean and variance to avoid overflow issues. Use numerical methods that are more robust to large values.